Healthcare is growing in many different settings. Nursing professionals are assuming increasing responsibilities in every aspect of medication administration. The first step in assuming this responsibility is learning to calculate drug dosages accurately for patient safety. After this lesson, you should be able to safely mix medications using evidence-based protocols, comprehend dosage calculation based upon evidence, and apply dosage calculations using evidence-based procedures through dimensional analysis. The drug administration is a process involving a chain of healthcare professionals. The prescriber writes the drug order, the pharmacist fills the order, and the nurse administers the drug to the patient. Drugs can be life-saving or life-threatening. Every year, thousands of deaths occur because of medication errors. Errors can occur at any point in the medication process. Each person is responsible for the accuracy of the medication order. Okay, we're going to discuss reconstituting medications. You want to remove caps from the medication and the diluent in vials and clean the vial tops as instructed by facility policies. Make sure you read the label or package insert to determine the amount of diluent to be injected into the vial of powdered medications. Then you will draw back the plunger on the syringe to the amount of diluent determined in step 2, and then air will be drawn up into the syringe. Insert the needle or the vial access device if using a needleless system into the vial of the diluent and inject the air. Do not remove the needle from the vial or don't remove it from the access device if you're using the needleless system. Turn the vial upside down and withdraw the required amount of diluent into the syringe. Withdraw the needle or vial access device from the vial. Insert the needle or vial access device into the vial of the powdered medication. Inject the diluent slowly into the vial. Then you want to mix the medication as instructed by the drug label or package insert. You need to be careful because some medications you're not allowed to shake. You have to roll it back and forth in your hands. Then withdraw the required amount of medication into the syringe and remove the needle from the vial or the needleless access device. So what is dimensional analysis? Dimensional analysis is also referred to as the factor label or the unit factor method. Dimensional analysis is an equation-solving technique commonly used in science to understand complex physical states. It is a useful tool for solving problems in which the properties or dimensions of two or more quantities are related to each other but are expressed in different units of measure. One of the quantities must be converted to the other by using a common equivalent or conversion factor. Dimensional analysis is particularly helpful in calculating medication dosages. Medications are ordered and supplied in a wide range of dosage, such as units, teaspoons, milliliters, micrograms, milligrams, or milliequivalents. Traditional methods of calculating dosages rely on memorizing formulas or performing a multi-step ration and proportion calculations. By following the steps of dimensional analysis, healthcare professionals can solve simple and complex dosage calculation problems easily and accurately. Okay, so to explain dimensional analysis, step 1, you want to establish the answer's unit of measures, and you can do this by asking what must be determined or how should the final answer be expressed. Then step 2, insert the given quantities. These are the amount of material or physical property specified in the problem. Step 3, determine the necessary conversion factor. This is a common equivalent needed to convert between systems of measurement. Step 4. Calculate the answer and examine the equation. Step 5. Critically evaluate the answer and ask these questions to evaluate your answer. Is the equation set up properly? Is the conversion fraction correct? Is the math right? Recheck the calculations for computational errors. Make sure that all units have been canceled properly. And does the answer seem reasonable? Is it even plausible? And then kind of remember these key points. The unit you want to find must always appear in the numerator or top of the fraction. And to eliminate a particular unit of measure in the numerator, use a unit fraction with that same unit of measurement in the denominator. Okay, we're going to calculate using weight. Our first example is a provider orders bivalirudin 0.75 milligrams per kilogram, IV 1 dose today. The patient weighs 74.6 kilograms. Calculate the dosage, milligrams, of bivalirudin that the nurse should administer. Round the answer to the nearest whole milligram. So step 1, first you read the question and decide what is the unit of measure I need. In this example, milligram is the unit of measure needed. Secondly, I want to insert the given quantities. The order is 0.75 milligrams per kilogram. That is one given quantity, and the other given quantity is 74.6 kilogram, which is the patient's weight. I need to be sure to place my milligram quantity in the numerator. Then the third step, I need to review if there is a conversion factor needed. Well, I have a milligram, and I have a milligram with a kilogram, and I have a kilogram. Therefore, I do not need to use any conversion factors. Now I want to calculate the problem. I need to know how many milligrams total I want to give the patient. The order provided was to give 0.75 milligrams per kilogram of medication. My patient weighs 74.6 kilograms. So I need 0.75 milligrams for each kilogram to get the amount I need. I am able to cancel out the kilograms. This provides me with the answer of 55.9 milligrams. And using the rounding rules, because the example states to round the answer to the nearest whole milligram, so the answer is going to be 56 milligrams. Okay, so let's work on another problem, except this time we will work with IV fluids. The example provided is the provider orders to infuse D5W 1 liter over 10 hours. To what milliliter per hour flow rate should the nurse set the pump or controller, and round the flow rate to the nearest whole number? So following our steps, I first need to know what unit of measure I need. Well, the example wants to know what the nurse should set the milliliters per hour rate on the pump. So next, what given quantities do I have? Well, I have 1 liter over 10 hours. Next, do I need to use a conversion this time? I have 1 liter over 10 hours. I need milliliters per hour. Yes, I need to convert my 1 liter to milliliters. So 1,000 milliliters is equal to 1 liter. Now that I have the conversion rate entered, I may now cancel out the like units that are placed in the denominator and the numerator. That will leave me with what I am looking for, milliliters per hour. Now I need to start my calculation. What I'm going to have in result is 1,000 milliliters over 10 hours. I will continue to calculate using division. I will divide 10 hours into 1,000 milliliters. This will bring me to the answer of 100 milliliters per hour. Okay. Okay, so let's talk about some insulin infusion. The amount of insulin that an individual with diabetes needs depends on numerous factors. Most types of insulins come in a concentration of 100 units per milliliter. This is located on the insulin package labeled as U-100. Only regular, short-acting insulin comes in two different strengths. There is U-100 and U-500. U-500 is more concentrated and provides 500 units of insulin per milliliter. This highly concentrated insulin is prescribed for individuals who are severely resistant to insulin and require very large doses. Insulin may be administered intravenously to treat individuals with extremely high blood glucose levels. Most intravenous protocols use regular insulin. However, several of the rapid-acting insulins, such as insulin aspart and insulin glutamine, may also be infused intravenously. Standard IV insulin dilution for infusion is usually 100 units of human regular insulin in 100 milliliters of 0.9% sodium chloride solution. So in other words, you have the ratio of 1 unit to 1 milliliter. The rapid and short-acting insulins have a relatively fast onset of action, allowing the nurse to adjust or titrate the insulin infusion based on the patient's current blood glucose level. Generally, a standard insulin infusion algorithm is used during insulin infusion. Each hospital has their own protocol. The protocol should include the type of insulin to be infused and directions for dilution, how often the patient's blood glucose is to be checked, the infusion amount, and the target glucose range. Here is an example of an insulin infusion algorithm. Heparin is an anticoagulant that does get ordered intravenously to treat thromboembolic disorders. It's available in commercially premixed solutions of 1,000 units in 500 milliliters of 0.9% sodium chloride solution, 2,000 units in 1,000 milliliters of 0.9% sodium chloride solution, 20,000 units in 500 milliliters of 5% dextrose solution, and 25,000 units in 250 milliliters or 500 milliliters of dextrose solution. It must be calculated per milliliter per hour and units per hour to eliminate any errors. Most hospitals have protocols for intravenous heparin. Here is a sample weight-based IV heparin administration protocol. If you note, titration infusion rates and/or dosages are based upon lab results of a PTT. Okay, so now we'll work on another example. A provider orders methylprednisolone 0.05 milligrams per kilogram per minute for a patient who weighs 67 kilograms. The infusion bag contains 200 milligrams of the medication in 100 milliliters of D5W. Calculate the milliliters per hour infusion rate and round the answer to the nearest tenth of a milliliter. Okay, so remember the steps. Step 1, what is the unit of measure I want? Well, I need to calculate the milliliters per hour infusion rate and round to the nearest tenth of a milliliter. Next step, what are my given quantities? Well, it's 0.05 milligrams per kilogram per minute times the 67 kilograms times my dose on hand of 100 milliliters with 200 milligrams of medication in it. Next step, do I need a conversion factor? Well, yes, I do, because I need to know exactly how much of the medication I need based on the patient's weight and calculate the rate. Well, the conversion factor I need will be to convert my minutes into hours. Now I can calculate. First, I want to cancel the like quantities that are divided by themselves. That will leave me with milliliters per hour as a result. And now I can multiply my remaining numbers. And the answer is 100.5 milliliters per hour. Since the number 0 is in the hundredths place, rounding to the nearest tenths leaves me with the 5 in the tenths place. Okay, so let's figure this if you had to have micrograms per kilogram per minute. Basically, you're going to set up the problem the same, other than you would use two conversion factors. You would use one for the micrograms and milligrams, and then you would use one for the minutes and the hour. Okay, there's another way that you can do calculations made easy. Remember that the other technique is that you just remember doctor's order divided by the concentration dose on hand multiplied by your supply or the quantity of medication you have equals the amount that you're going to administer. This link below provides some review of some calculation examples. There's also a YouTube video link that will be provided after this lesson in another little section for you to review some calculation examples. This concludes the mixing medications and dosage calculation lesson. If you have any questions related to this lesson content, contact the instructor. You will be provided with practice math questions for the remaining weeks to follow. In ASN 210, you will be completing a math exam.